we're not even going to talk about this. Very little weather going on weather-wise. So we're going to look to all the different corners of the country and see if anything else is going on. A lot of problems with wildfires in California. We've got 3.9 million acres burned, 8,100 wildfires, 30 deaths to date, and about 7,000 structures lost. We were looking at a pretty serious situation yesterday. I'm not seeing a whole lot of activity today except with the Sequoia fire located down here. The Glass Fire in Napa County has been active. Also, the Zog and August complexes up in this area had been combining into a single fire. So I don't know where we're at for today, but Mike R., one of our viewers, did report another round of fires yesterday was going up over the wine country. Maybe we can take a look at that. Let's turn that satellite loop back. So yeah, this is yesterday morning. And you can see Napa County right in this area. It does look like a fire was getting going, and these were flaring up, so I think maybe we're looking at a better situation today. But Mike R. did say that the offshore wind event, the low humidity, all that made for extreme fire danger, and he's looking forward to a possible pattern change early next week with the tropical moisture flowing in. And let's take a look at that precipitable water. There's Friday, Saturday, Sunday, and then Monday. And it looks like gradually during the week, around midweek to late in the week, yeah, we do start picking up a little bit of moisture. It's certainly not a Pineapple Express or anything like that, but it looks like by about the 11th or 12th, we do start bringing in this northwesterly flow, and that should increase the relative humidity and bring in pattern shift. Now, elsewhere around the country, I'm going to back up that precipitable water. You can see the high pressure in the Dakotas pretty much clearing out most of the central and eastern U.S. So that cold air with dry conditions is pretty much the roll into late in the weekend. And there we go. Sunday looks like we have our funnel system developing there in Texas. And you can see not a whole lot of development with that. We get another burst of cold air coming south. However, it does look like we're trying to bring up that moisture. It's kind of scarce, but as the week goes on, another outbreak of cold air late in the week, but you can see this tropical moisture lurking on the Texas coast, and that is going to get pulled up and really change the patterns by next weekend. Not this weekend, but the next one. See that right there? There's 2-inch precipitable water amounts coming up into Texas, so that's going to mean rain for that part of the country. And if we go a little further, well, look at these pressure falls here in the Rockies. Moisture lurking to the south. This is on October 11th. Okay, now watch what happens. That moisture really comes north, and we're talking, 2 to 2.5 inch amounts precipitable water. That's going to mean a squall line. So we're talking about the middle of the week, maybe the 14th or 15th, probably a large MCS moving eastward. But that's quite a ways away. And the GFS trying to bring a little tropical storm into the Gulf of California. That could be interesting too. That could mean a lot of rain coming into Arizona. But look how far out we are, 372 hours. We'll just have to see what happens. So the two areas we're going to be interested in is tropical cyclone production and cold air production. So let's see what we're looking at for the week ahead. 5-day outlook. Yeah, that's showing a little bit of activity starting up around the Yucatan, the far western Caribbean. So depending on how those systems move, there could be some influence on Texas maybe in a week. Now, looking at that, I would probably want to take a look at the European model too to see if that brings in any tropical activity. Now, when we looked at the precipitable water, I was checking this area here, and we start out with a northerly gradient. Let's see here. Yeah, it does look like a little tropical cyclone at the very bottom of the map, and I think that surge coming into Texas was probably advected northwest by that tropical cyclone. So no real problems according to the GFS. We're just going to get the moisture. But let's check out the European model. Yeah, the pressures do look low down at the Yucatan, and I think it's following a similar solution to the GFS. Just kind of stormy down there around the Bay of Campeche, and eventually we get the moisture into Texas. And as far as cold air outbreaks, the European model does a pretty good job with that. There's this evening's map showing a cold outbreak into the Midwest and the Great Lakes area, the worst of it over Minnesota, where temperatures are about 10 to 15 Celsius below normal. So that slug of cold air is heading for the East Coast. You can see some rapid modification there as it approaches the Appalachians, and even that little shot going into Kentucky and Virginia. By Monday and Tuesday, it pretty much vanishes. And then we get this warm pattern in the west and the central U.S., and some of that is going to work eastward with that very strong westerly flow. Look at that warm air heading into the eastern U.S. And then the next shot of cold air coming down around midweek. So there's your fronts right there. That moves on to the East Coast. Cold once again for New York, and they're going to really be feeling the effects of that a week from now. And here's the next cold air outbreak about to come down, and looks like a lot of warm air heading northwest or northeast. Yeah, temperatures in this stuff 15 to 20 Celsius above normal. That sounds to me like 90s. So not much cold air associated with that outbreak, and we generate even more warm air. So it looks like a tall order getting any cold air down south, but California, yeah, that looks like a very potent Pacific system coming inland around the 10th or 11th. So that'll be something to look forward to, and maybe that'll bring some rain. A quick look at the upper air charts, 250 millibars, shows a meridional pattern, which means a lot of transport of heat north and south, warm air going north into the Gulf of Alaska, and cold air coming south into the Great Plains. And likewise, warm air going into the Labrador Sea area and the far northern Atlantic. So eventually this should work itself out, and we'll get back into a zonal flow, and that's probably going to be a big reason why we're not getting much in the way of cold air moving southward. And we can see that work itself out on the GFS chart. Yep, pretty much a transition to zonal flow around midweek next week. A few troughs mostly affecting the East Coast, and out here in the Pacific, very long band of zonal flow. You know what that means. Increased amplitude, and boom, there's our wave out there in the western U.S. around the 13th or 14th. So based on that, I think that's good enough evidence that around the 12th through 14th, we may be seeing a stormy pattern in California. Okay, time to take a tour around the U.S. and look at the weather. In the northwestern U.S., things dominated by this 1030 millibar high across the Dakotas. And that's given us northerly flow in Minnesota, temperatures 54 at Minneapolis, looks like about 50 at Sioux Falls, and then on the other side just kind of a very weak pressure gradient. But there in Alberta we do see a lee side trough. That should not be a surprise because we do have some upper level flow from west to east. You can see that there on that GFS chart from this morning. Pretty good westerly component across the Rockies, and that's going to mean the lee side trough will get established just east of there. And there we go. We'll run a quick satellite animation And out over Minnesota and the Dakotas, that's the cold air advection. Remember the ridge and the high pressure located right in that region. So this area here under northerly flow. And the clouds there due to rapid modification of a unstable air mass. And kind of the inverse effect on the other side of the high. Here we have a very weak gradient. We've got warmer air flowing north, where the air mass is cooler, so that means we're going to get a little bit of stabilization taking place. So not very much going on in the low levels. Most of what you see here is mid and upper level clouds, moisture from the Pacific riding over that ridge, and there's enough moisture for us to see visible cloud material. In the southwestern U.S., it is clear. Really not much to see except there in Texas, some of the smoke from the wildfires, currently across northeast Texas. And then, of course, we got the wildfires in California that we talked about earlier. There's a map for the southwestern U.S. Got that heat low over Arizona, but you can see the effect of all this cool air flowing south. Even though the temperatures are up above 100 in Phoenix and Imperial, El Centro, there's not enough cold air to really make much of a difference. But you can see the effect in the pressures. Typically, we see pressures around 1005 to 1006, 1007 when we have a heat low there in August and September, but now we've got something more like 1012, which is a little elevated. And that's due to the influence of the cool air kind of gradually flowing down. But it is getting heated pretty quickly. And let's see, out in Texas, yeah, the ridge all the way down into the Edwards Plateau, the hill country, and anywhere east of there, we've got the northerly flow. There's a satellite loop for the southeastern U.S. Well, yeah, this all looks like cold air advection stratocumulus, so we're going to be looking for that on the analysis. And it looks like this region under the influence of a jet stream. Could be a subtropical jet, could be a polar front jet. There's our weather map for the southeastern U.S. The story on that, high pressure to the west, lower pressure to the east, but it looks like our front is offshore. Let's take a look at a couple of example soundings. Let's try Lubbock. And we'll go east to Memphis, and then we'll go further east to, I guess that would be Raleigh, somewhere in that area. So we can see that we go from this high pressure, much warmer conditions, and just gradually cool as we get closer to the back end of that cold front. So for Lubbock there, Skew-T is going to look like this. It's pretty nondescript. It's dry. A couple of stable layers due to a little bit of warm air aloft. And we see a very steep lapse rate due to the strong heating in the lower levels. The winds certainly influenced by that surface high, but they transition to westerly flow aloft. And that's due to the influence of that upper level ridge in the western U.S. Going further east into Memphis, so there we've got a very steep dry adiabatic lapse rate. Now that right there is not just due to strong solar heating. I mean, that's part of the story. What's really happening there is there's a tremendous amount of modification of the air as it rolls out over that warmer terrain. See these temperatures here, 7,000 to 8,000 feet off the ground, almost freezing. That's that cold air flowing in from the north. See that right there, 30, 40 knot winds coming in from the northwest, elongating that hodograph. So some of that cold air is being mixed down to the ground, and warmer air is being replaced from the surface. So that kind of mass continuity going on takes place and gradually equalizes the lower levels. And we'll go further east into North Carolina. And what we're seeing on that graphic is pretty much southwesterly flow. based on this, I'm not sure very much of that cold air has made it down there. Looks like deep southerly flow. And also, remember how at about 7,000 or 8,000 feet in Memphis, it was almost freezing. That's not the case there. Temperatures are closer to 50. So I'm not 100% sure that this is a cold air mass. I think there's been something going on between. So maybe I should bring this back. Let me go back to Atlanta. Okay, here there's a little inversion, slightly north component to the winds. And something that we don't often talk about is the inferred temperature advection. That's kind of calculated here based on the rotation of the winds with height. That's basically the thermal wind relationship. And what that's telling us is that there's cold air advection just above the surface, which kind of pairs well with what we're seeing here. That's probably some of the cold air coming down. And let me set it a little further west into Alabama. Yeah, that's looking more like a modified cold air mass. So, based on that, I might have to bring that front further back. This is probably the old front, and then I think we've got a fresh outbreak coming in, something like that. And yeah, there's that south wind right there. So yeah, the pattern is a little bit more complicated than I originally thought. 78 there at Roanoke, Richmond. No, Roanoke's out west, isn't it? Yeah, Richmond. So certainly don't be afraid to change your analysis, because there may be features that you're not really seeing the first time around. Okay, looks like a little cyclonic rotation going on in New England. I don't really see a closed low in there. Well, maybe a little one. Is that a frontal feature? I'm not 100% sure. There could be. I don't know. That could connect back into the system down to the south. And then the warm front coming up like that. And these are little cold air advection troughs. There's the potential for those to become baroclinic as well, as with any cyclonically curved trough that induces convergence along its length. And then for the northeastern U.S., yeah, very clearly a vast area of cold air advection and a couple waves embedded in the flow. There's a closer look at those cells. Even though temperatures at the surface are near 55 to 60, we're still getting these shallow cumulonimbus clouds. And we roll the animation forward. And you can see they put up some anvils, they build, and then dissipate. Why don't we take a look at the Skew-Ts in that area? Well, there you go. That's how the cold air advection cumulonimbus is going to look on the model charts. And let's drop a forecast sounding in eastern Michigan. And that's a very steep lapse rate. Just enough moisture to get those towers going. You can see the Cape, not that great, but it is there. In fact, let me see if I can sample that a little bit better. Go down to Detroit. Just not very much Cape, about 300 to 400. Probably the spots of surface heating are helping out a little bit as far as that goes. But you can see the air mass is uncapped. The cells are just going up wherever they can. And there's not very much shear. That little extension that you see on the photograph where it's yellow and turquoise, that corresponds to this yellow and turquoise right here, and we can see that's pretty much up near the tropopause and above, so we can discard that wind. So a poorly sheared environment, unidirectional, that's going to mean not much storm longevity. And with a limited Cape, they're likely not putting out any lightning or anything like that. It's probably just kind of showers of rain passing through and then you get the sun breaking out. And that'll bring this edition of Forecast Lab to a close. And it's time to do our drawing of the Instability Skew-T and Hodograph Handbook. We've had 7 new signups in September. And there's the list. I just kind of added them in no particular order. And we're going to roll an 8-sided dice to find the winner. Okay, here we go. We're going to put the dice inside and then shake the box. And go ahead and do that. And we're going to shake it. And what's the result?
7.
Okay, 7's the winner. So congratulations to Brian Schrader. We'll contact you via Patreon or your address if we have it, or you can contact us. And so that's all we have for this edition of Forecast Lab. We'll see you all again tomorrow for our Friday edition. Take care and have a good one. Bye-bye.